In this class, we're going to talk about linear inequality. Let's start by learning how to identify the the signs of inequality that is present in these questions. Okay, these are the questions that I'm going to solve. Okay, now look at the first question here. What is the name of the sign that is present? Which inequality sign is present in the first question? Recall, in our previous class, we discussed the 4 common signs that we make use of in inequality. This includes the greater than, the less than or equals to, and the greater than or equals to. So, among those 4 inequality signs, which sign is present in the first question? The sign is greater than sign. The sign is greater than sign. If you are part of our previous class, you will know that the sign is greater than sign because I take time to explain. Now look at the second question. Which sign is present? What's the name of the inequality sign that is present in the second question? The sign is less than. That is less than. Then let's proceed to the third. What is the name of the inequality sign that is present here? The name is greater than or equals to. So here we have greater or equals to. Then for the fourth question we have, what is the name of this sign? You see, what is the name of this sign? The sign. Okay, how do you identify that this sign is a greater than sign? If you are given this in the exam, maybe you come across this in maybe exam questions, how do you identify that this is a greater than sign? I give you an analogy. Just look at your right arm. If you do your right arm like this, you will see that this is a greater than sign. This is the less than sign, and this is the equals to sign. I mean, less than or equals to, then greater than or equals to. You understand? So, using the same approach, you can see that this is how the sign look like. Using your right arm, this is a greater than sign. Okay? Then greater than. Then for the fifth question, the sign there is greater than or equals to, greater than or equals to sign. Okay? Then the sixth question, the sign that is present is greater than. You understand? The sign that is present here is greater than. As you can see, we have something like this. And for the seventh question, the sign that is present there is greater than or equals to. So I'm going to have greater or equals. So I just take this as just a reminder. This is just a reminder of what we learned in our previous class. Okay, so for eventually you missed the class, kindly check the description. You're going to see a link there. Click on that link to watch the first class. Okay, now let's start with the first question. How do we solve for the value of x? What are the values of x that satisfy the range of this inequality? We have 3x. Okay, solution. We have 3x. Okay, 3 plus x is greater than 7. Okay, what are those values of x that satisfy the inequality? Okay, now don't forget I gave you 4 steps when you are dealing with linear inequality. The first step is that you have to simplify the inequality by collecting like terms. You understand? Okay, so here you can see that 3 is constant and 7 is as well constant. So they didn't have any variable. So I'm going to move this 3 to the other side of the equation. So the equation becomes like this: x is greater than 7. Now, if this 3 crosses the inequality side to the right hand side of the equation, it becomes negative. So I'm going to have negative 3. So here I'm going to have x is greater than 7 minus 3 is what? 4. So x is greater than 4. So the values of x that satisfy the inequality signs are those values that is greater than 4. This includes 5, 6, 7, 8, and so on. You understand? Those values are they satisfy the inequality. 3 plus x is greater than 7. You understand? Okay, let's proceed to question number 2. We have 3t is less than 6. 3t is less than 6. How do we solve this inequality? All you have to do is that you just have to divide both sides by 3. You understand? Now, if you want to divide both sides by 3, we're going to have this divided by 3, this divided by 3. So here, the value t will be less than 2. So the values of t that satisfy the inequality are less than 2. Do you understand? So are those values that are less than 2? This include 1, 0, negative 1, negative 2, negative 3. You understand? So those values they are less than 2. Okay, so let's proceed to the third question. We are given that z minus 2 is greater than or equals to 5. That is question 3. Z minus 2 is greater than or equals to 5. Okay, looking at this question, I want you to pay attention here. You just have to simplify by collecting like terms. You understand? You simplify the inequality by collecting like terms. So if I want to collect like terms, I'm going to have z. Now, if this negative 2 crosses the inequality sign, the sign is going to change to positive. So I'm going to have 5 plus 2. So I'm going to have here z is greater than or equals to 7. So the values of z that satisfy the inequality z minus 2 is greater than or equals to 5 are those values that are equals to or greater than 7. This includes 7 itself, 8, 9, and so on. Okay, so let's proceed to question number 4. We are asked to solve 4x plus, okay, we are asked to solve 4x plus 1 is greater than x plus 5. 4x plus 1 is greater than x plus 5. Okay, don't forget the first step. The first step is that you have to simplify the inequality by collecting like terms. Like terms are those terms that are similar in the equation. You understand? So if you want to collect like terms here, I'm going to have 4x. Now, if this x crosses the equals to sign to the left hand side of the equation, I'm going to have negative x because the sign that it carries before is positive. So I'm going to have negative x. Now, this one will crosses the equals to sign as well to the right hand side of the equation. So the sign is going to change from positive to what? To negative. So here I'm going to have is greater than 5 minus 1. Okay. So 4x minus x will give us 3x. So I'm going to have 3x is greater than 4. So don't forget we are looking for x. Okay. We are asked to determine the range of x. So I'm going to have this divided by 3 and this divided by 3. So here x is greater than 4 over 3. That is the answer. Okay. Let's go to question number 5. We have x plus 2 is greater than or equals to 5. X plus 2 is greater than or equals to 5. So this is simple. I'm very sure you can solve this. All you have to do is to take these two to the right hand side of the equation. So the equation becomes like this. X is greater than or equals to 5 minus 2. So x is greater than or equals to 3. That is the solution to the question. Okay, let's proceed to question number 6. We have 3z plus 2 is greater than z plus 3. 3z plus 2 is greater than z plus 3. Okay, now all you have to do is to collect like terms. Okay, so if I want to collect like terms, I'm going to take this z to the right hand side and this plus 2 to the, this z to the left hand side and this plus 2 to the right hand side of the equation. So the equation becomes like this: 3z minus z greater than 3 negative 2. Okay, so 3z minus z, that is 2z. Here I'm going to have greater than 1. Here I'm going to divide both sides by what? By 2, because the goals is to divide. The goals is to determine the range of z. Okay, so here I'm going to divide by 2. This divide by 2. So z is greater than 1 all over 2. So that is the solution to the question. Now I want to do something now. Attempt this question, which is question number 7. I want to attempt this question. Okay, so if you got the answer right, the answer, okay, let me give you the answer. Negative x greater than or equals to negative 1, negative 5. Okay, that will be negative x greater than or equals to negative 6. So if you divide both sides by negative 1, this over negative 1, you're going to have x is less than or equals to 6. Do you understand? You know, one of the important points that I gave you in our last class is that when you are dividing an inequality, maybe you are dividing an inequality equation by a negative sign, the sign of the inequality have to be reversed. You understand? The inequality sign needs to be reversed if you are divided by a negative sign. So you can see that when I divide both sides by a negative 1, you will discover that the sign is reversed. Instead of greater than or less than, I have less than or greater less than or equals to, sorry. Instead of greater than or equals to, I have less than or equals to. So that is what it means. So let's say you are given this question. Hello, pay attention. Let's say you come across this question in exam. X, minus 2x is less than 4. You are asked to solve for the value of x. I mean, what is the range of the value of x? You just have to divide by negative 2. This over negative 2. So I'm going to have x is, because the sign is less than before, is going to change to negative greater than, because I'm now dividing by negative 2, and 2 is a negative number. Negative 2 is a negative number, you understand? So the sign is going to change to greater than. If the sign is greater than before, the sign is going to change to less than. If the sign is less than before, the sign is going to change to greater than. If the sign is less than or equals to, the sign is going to change to greater than or equals to. If the sign is greater than or equals to, as in this case, the sign is going to change to less than or equals to whenever you are dividing an inequality equation by a negative number. So here I'm going to have x is greater than 2. You understand? So that is the simple analogy behind this concept. Okay, so with this we are going to progress in our next class. You know, these are just the basic concept that you need to know. So if you have any question regarding this, let me know. Okay, let me know, and if you understand, let me know as well. If you have any question, let me know. So that will be all for this class. See you in the next class.